Hi there, Jay Tedeschi here, Senior Technical Marketing Specialist with Autodesk. Today we're going to take a look at mechanical concept and layout design using Inventor Pro 2016. We're going to start here in Inventor by importing an AutoCAD mechanical layout drawing. For lots of companies and for lots of us, initial concept design and layout is done in a 2D design tool, and there are very few 2D design tools that are as good as AutoCAD and AutoCAD Mechanical. What we're doing here is utilizing one of those layouts, and it's a layout where we utilized both layer and block structure in the AutoCAD drawing to define assembly structure. That assembly structure can be passed intelligently into Inventor, into a 3D environment. So we're going to show you here how to utilize that existing DWG data as the backbone of a fairly complex Inventor assembly. So we're starting here by pulling the AutoCAD DWG data as well as the block data onto into an Inventor part, and more importantly onto an Inventor sketch plane. We'll start by saving this. So this is going to be our layout. This is a particular type of, it's not technically skeleton modeling with regard to how skeletal modeling has been defined by industry, but it is in fact a technique, a skeleton type technique, as we're going to have a single IPT file which is driving our entire assembly. Now, as you can see, if you look here, we have all of the blocks which were originally defined in AutoCAD are now also defined here in Inventor. Now we're going to use the make components command here to basically write out an assembly document that has all of these IPT files and these blocks, which were, admittedly they were just blocks in AutoCAD. They're referred to here on the IPT file as sketch blocks, but now, as you can see, once we push that to an IAM file, these are now automatically turned into IPT files and IAM files based on how deeply nested those blocks were, and as such these will form the backbone of our new assembly. So we'll start by grounding a couple of the components which will not see any motion. And now we can start to assemble the structure of our assembly utilizing assembly constraints. So we'll add a mate constraint between those two axes. And now you'll note that I can essentially test the motion of my assembly by dragging the component in Inventor, just as I would with any 3D component. So over time, we have fleshed out the assembly, and again, this is all based on that initial 2D Inventor IPT file that was created from the AutoCAD drawing. Now what we're going to do now is utilize some new methodologies with leveraging AutoCAD data, and this is called DWG underlay. Now we're going to use this drawing that we have of the gripper side plate to essentially poach data. Now the nice thing about using DWG underlay as opposed to the paste methodology that we used a second ago when I initially started this with the AutoCAD drawing is that this is a live link to the AutoCAD data. So we're essentially just moving the entire AutoCAD drawing into position where we want it relative to the rest of the components in our Inventor assembly file here. We'll use this locate functionality to pull it into position. Now, snap to, and let's pick this point right here. And now it is positioned relative to the rest of the components in the assembly where I need it to be. So to create the part based on this data, we'll create a sketch, and now we're going to use a special type of projection. It's to project DWG data, maintaining a live link to that data. We'll grab enclosed loops. So we'll grab these circles here. We'll grab the outer profile there. And let's zoom in a little bit. Well, now what we're going to do is add a dimension. This dimension is going to be used. We can't utilize, using DWG underlay, we're not allowed to utilize the dimensions that are on the AutoCAD file, but we can add reference dimensions here in the sketch environment, and that's going to be used to drive that reference dimension is live to the DWG data, and it's also going to be used to drive the thickness of my plate. So we'll select that reference dimension there. So we now have a 6 millimeter thick plate. And with that, let's turn off the visibility of the AutoCAD DWG file itself. Go ahead and mirror our existing gripper plate. We'll mirror about this plane. Let's change the name here to -002 instead of mirror, which is the automatically assigned suffix. So very quickly now we have created our gripper geometry directly from the DWG file. Now you may wonder what's the advantage of using this as opposed to using the methodology we utilized in the first place, and I'm about to show you that. The advantage is that, again, as I pointed out previously, DWG Underlay maintains a live link to the DWG file, which for many companies this is still an active document. There's no right or wrong way to do design. The right way is the way that allows you to be productive, and for some companies that productivity hinges on the use of AutoCAD as their design tool or their layout tool. So by modifying the dimension here, changing from 30 millimeters to 35 millimeters in the DWG file, when I get back to my Inventor assembly and update, you'll see that the change is driven automatically. As the DWG file changed, so does the IPT file in Inventor, which is based on it. Now we'll utilize direct editing here in the model to change the diameter of the pin, the shear pin that passes through that hole, and we know it was 35 millimeters, so let's go ahead and just change the diameter to 35 millimeters. We match the diameter of the hole in our gripper plate, and that's it. So with that, I want to thank you for your time, and I look forward to speaking with you all again very soon.